All right, friends, welcome. Welcome to another episode or cast stream, if you will, of GitHub Enterprise on Twitch. Thank you so much for being with us. We're really excited to be here through this medium to just, have a discussion with you and share some of the topics that are top of mind for us and top of mind for the customers and developers that we speak to every day. So it's really great to be here. I'm also joined by my colleague, Jonathan Cardona, who is a solutions engineer for GitHub. You can see him in the chat. His name is, or his tag is Hollywood. And so if you have questions, comments along the way, feel free to message me. It's Alwell Kevin, very similar to my GitHub handle. And his is Hollywood. And again, so my role is very similar to Jonathan. We are solutions engineers for GitHub. And what that means is we have a tremendous privilege in that we get to speak with enterprise customers and understand how they're using and adopting the platform, and understand that, how our new capabilities that we're shipping kind of align with their goals as an organization. So what we're going to be sharing with you is how to achieve DevSecOps maturity with GitHub. It's going to be hands-on. It's going to be slightly technical. So hopefully folks on the line have an appetite for that. And I saw some people already chatting and asking about, like, who is this stream good for? Who is this content prepared for? So really, I think any developer, anybody who's planning out, either an adoption and scaling of GitHub Enterprise or an exploration of GitHub's advanced security or AppSec capabilities can get something from this stream and this content. So if you're here, we're grateful that you're here, and we think that there will be something for you. Now, just as we kick off, I'm going to go ahead and share my screen and share a resource with you right out of the gate. So this is an ebook that we shipped recently. And basically, it's going to walk you through a lot of the content that we're going to go through together today. Okay, and so what I would encourage you to do is, and Hollywood, if you don't mind, if you could just paste this link back in that Twitch chat so folks have it. I'd encourage you to come along to this site, download the PDF, and follow along on your own. And there's a few ways you can do that. If you're an enterprise customer who already has advanced security, then you'll actually see those capabilities surface in your interface. Otherwise, if it's something just that you're exploring and you want to just watch, totally fine too. Or, if you're an open source developer and you have projects just on github.com that are public, you can actually sign up for our beta if you haven't already. And Hollywood, one last thing I'll ask you, thank you so much. Can you share the link to sign up for our beta so folks who are interested in that can get access along the way? So again, if you just joined, we're going to be talking about achieving DevSecOps maturity with GitHub. And we're basically going to be measuring our maturity with this OWASP framework called the DevSecOps maturity model. And we'll talk about what that means and what the levels are and what your program might look like as you achieve the various levels of maturity through the program. So go ahead, download this PDF, and we're going to go ahead and jump in a moment. Great. Okay, so I'm going to go ahead and do that. And again, I'm going to be monitoring the chat myself. So along the way, if you have questions, comments, if you want to just modify what it is that I'm sharing with you, we're totally open to that feedback. And we want you to get the most out of this stream, right? It's fun, and we love engaging with you as an enterprise community or as the developer community. But really, this is an opportunity for you to pull from us whatever you need to accelerate your own development, right? So I'm going to go through the workflow that I encourage you to, which is to come to this site here. The link is in the chat. Hollywood just shared it. So download that PDF, and you should get access to something that looks like this. Okay, and you can go ahead and download that to your local, or if you just want to look at it on here for now while we're following along together, that's totally okay too. So I'm just going to talk through, before we actually get started with, what are the capabilities of GitHub that are going to allow us to enable DevSecOps at scale across our enterprise. I'm going to talk us through what this maturity model is and what the framework is, so we all have a baseline contextual understanding of what we're working towards, right? So let's just lay that out. So what we're going to be talking through together and what this white paper describes for you is really a framework that's been developed by this open source community for helping you understand not just your own organizational AppSec maturity, but also helping you understand how you can get to that next level and maybe what it means to achieve that next level in a healthy way as you're working towards implementing some of these capabilities. And the axes, or the kind of things that you would measure yourself on, that you'll explore in this e-doc as you read it on your own or as we work through it together. The axes are really 4 things that you're measuring yourself against, at least initially, right? To be really simple. So we want to measure against the static and dynamic depth, which is how comprehensive are the static and dynamic scans we're doing against our application in the CI pipeline. And so those are 2 axes that we're going to use to measure our maturity. Now, 2 that really stand out for me as somebody who's implemented these pipelines at scale using a variety of tools is intensity and consolidation. So those are the 2 other axes. So the intensity really means the frequency at which you're scanning your applications for vulnerabilities. And when we're talking about vulnerabilities in this context, it could be semantic vulnerabilities. It could be tokens that you've leaked back in your source inadvertently, right? Or it could be vulnerabilities through your dependency. So how frequently are we actually implementing those scans? And something I talk to our customers about all the time is, we have a conversation around, as an AppSec leader or a security engineer, how do I influence the developer workflows in a way that's healthy and productive and not a blocker, right? So actually what I would encourage you to explore is the possibility that at level 1 maturity, we're actually not going to block a developer's merge from the pull request workflow with our scans. And there's a reason for that. We'll talk to it, but I just want to lay that out there early on in terms of the intensity. Now, the last thing is consolidation. So that is the last of the 4. There was static depth, dynamic depth, intensity, and consolidation. So consolidation is really about how do you surface the insights in a meaningful way in order to actually remediate these vulnerabilities that are popping up across your developer workflows. And I want to be really specific about where they should be surfacing. Of course, you'll want to have that kind of organizational overview or the org level aggregate insight. But as a developer, I own the infrastructure, the operational aspects of the applications that I'm shipping. And increasingly, in the case of what we're talking about today, right, DevSecOps, if you will, which really should be included in any healthy DevOps program, as I've had conversations with folks along the way. How are we going to bring these tools together? How are we going to enable developers to own the security of the applications that they're shipping and make that actionable, right? So, that's just a little bit of an overview. I wanted to talk through what it is that we're actually measuring ourselves against. What is DSOM as a kind of short way to say the DevSecOps maturity model? Go ahead and download this document if you haven't already and you just dropped in. We're going to be walking through an implementation together. So thanks all for joining. Okay, so go ahead, and as you're working through this, we're going to start scrolling through and either reading through what the DSOM is if you want a little bit more detail, or trying to understand at the next level, right? If we understand the baseline of what DSOM is, how do we define what level 1, what level 2, and all these different tiers are of this framework, and how do we actually get there with GitHub tools? That's what we're going to be building together. So a few characteristics, just a few notes that I recorded myself because I thought they were interesting points to share with you, just based on, again, the privilege that I have to have conversations with all of you, with our enterprise customers who are actually rolling out these capabilities at scale across their orgs on GitHub. And again, one of those key capabilities at level 1 as you're rolling out your AppSec program is to not be a blocker as a security team, right? We all say that, and we say, hey, we want to partner with the development teams. And one way to do that is really to begin by surfacing the insights and saying, hey, we noticed something in your pull request, and there's a certain probability that you should go back and actually see if that vulnerability is worth looking into, right? Versus saying, hey, you can't move on to the next step. You can't actually merge this feature until you patch this thing that may or may not be a legitimate vulnerability. And so we want to enable some degree of knowledge transfer as well. And so what I've seen as a really healthy practice along the way is a champions program. So if you don't already have these security champions across your own org, I'd encourage you to identify who those people are or step up as that person. And as that person, what your role really is to understand from a security perspective what the AppSec program is and what the team's trying to roll out across the org. And then from the other side as a developer, how do I take the tools that are being provided to me and actually implement those in a way that delivers value but does not inhibit our ability to deliver features fast, right? And that's what we're going to be working through together. So we're going to go ahead, we're going to implement SCA using GitHub native capabilities. We're going to implement GitHub's native code scanning capability. And we're also going to walk through ZAP. So we're going to walk through just the open source DAST implementation of ZAP as part of our CD pipeline. So you may have been here in the past if you joined our first demo day where we actually walked through the CI/CD of this same application and defining those pipelines as GitHub Actions. So that's what we're going to be doing together first, is actually defining CI/CD pipelines for an application that we've built, and then actually implementing security as part of those steps within those delivery pipelines. And so we're going to walk through all of that together. Now, what I did want to share with you, even before I start walking through that specific implementation for a singular repository, is this example here. So you may not be familiar with this interface if, you're not a GitHub admin. So this is what your GitHub admins actually can see in terms of your org level settings, those higher level settings for GitHub Enterprise, right? And you may not also be familiar with some of these capabilities if you just don't have advanced security enabled. So don't be alarmed if you don't see something like secret scanning, or when I get into the code scanning capabilities, if you don't see that surfacing in your UI. You do need to have that feature enabled, and Hollywood did share some resources for how to do that. So we're gonna walk through that together. And again, work with your account managers or work with that beta link that Hollywood shared to get all this up and running. Okay. So all that's been said, I think we're all on the same page. We're going to talk about some security capabilities that we're providing for you out of the box as part of your experience, okay? And so what these are, it's really important to understand. What is really important to understand is that you can enforce these capabilities at a few different levels. I think what I wanted to share with you first is the org level settings, okay? And so you can standardize on some of these practices. In this case, it's SCA practices, software composition analysis, across all of your repositories. Okay, and so let me walk through what the dependency graph is and how you kind of benefit from that open source community on the platform of something like, I don't know, 50 million developers that are on the platform as being, an enterprise user, or just a user in general. So if you enable the dependency graph at the org level or at the repository level, we're going to have, as GitHub, an understanding of all the dependencies of your repository. We'll scan your manifest and actually understand what your footprint is, not just from your direct dependencies, but through your transitive ones as well. Okay, and so by checking this enable all box for all your repositories, you say, hey, GitHub, I want you to understand what my dependency footprint is. And why might you do something like that, right? What's the incentive there for me as an organization? So what you get from that are two really great capabilities, at least two capabilities. So you'll get the next feature, which is depend about alerts. And you may have seen this in your own personal development if you're an engineer or an individual contributor. You see the alert surface in the CLI, and we ignore them there. I know I do. In the UI and via email, right? But what's really great about this is taking it to the next level. So yes, you can enable this across your org. We'll send alerts to all your developers anytime there's a vulnerability in any of the projects that they're consuming, right? So here we understand what your dependencies are, and here we alert your developers if there are any vulnerabilities in the projects that we just found that you were consuming. The next step is, and you're actually twice as likely as a developer to patch a vulnerability in your dependencies over a 48-hour period if you enable this feature. So if you're an AppSec program manager, I encourage you, check out this capability and definitely consider enabling it for your entire organization. So what we do is we have this piece of automation that says, hey, I know that you have these dependencies in this project, and I know that there are these vulnerabilities from the GitHub advisory database attached to those dependencies. And so what we'll do is we'll open a pull request on your developer's behalf. We'll give you a compatibility score, which will give your developers an idea, hey, if I merge this update, am I going to introduce a regression or not, right? All the developer has to do is come in there and merge that PR rather than, going in, modifying the manifest and understanding what version they need to bump to and whether or not that's going to introduce a regression. So there's a ton of efficiency to be had there. So I encourage you to explore also enabling that. Now, the last thing, secret scanning, is exactly what it sounds like. I just love how explicit the name is here. Nobody needs to fish for details. We will continuously scan for any tokens for a number of service providers. I think it's something like 27 plus service providers that we support out of the box today. In the future, you'll also be able to define your own patterns to search for. And we can basically alert you through a very similar flow that you have with your Dependabot alerts. And you'll see soon in your code scanning alerts, if anybody's inadvertently pushed a token back to your repository. Okay, so there's no need to have, either pre-receive hooks or any sort of checks in your IDE. Everything's going to be ferreted out and elevated and made, transparent and just available to you as somebody who owns the AppSec program to review through Sequence. Okay, so I encourage you, if you have this capability, enable it. I've seen a tremendous amount of value for very large enterprise customers who turned it on, and it turned out they had, over 100 secrets that surfaced across their organization. So I definitely encourage you to click that enable all button here as well. But if you're not comfortable doing that, all of these capabilities also exist at the repository level. Okay, and so that's what we're going to be talking through. This is the project that I'm going to be working with you today, implementing CI/CD and what did we say? SCA, SAST, and DAST. So we got a lot to do. Let's go ahead and get started. So here's my repository. I actually, for this stream, I kept it private because there was a token that I had to leak in here in order for us to see what that experience is like. And obviously, we're going to have to invalidate that as soon as we share it. So all the hackers that are here don't start cloning my code. So I did have to push a token, so I kept this repository private. But again, I think if you've downloaded this document from the link that Hollywood shared, you should have most of what you need to implement this on your own in your own repositories. And so I encourage you to explore that. So the first thing that I'm going to do, I've already cloned this repo locally, so I cheated a little bit in that sense. But I'm going to go ahead and just make sure that I can stand up the application and run my tests locally before I actually push it back to GitHub and try to automate my deployments and everything. So let me go ahead and do that. So I'm going to open up my, my terminal here. And now you can see this big, nice terminal, getting some street cred, of course, for opening up the terminal on a stream because anything can happen. So let's go ahead, and the first thing we'll do is, I've already NPM installed. I'm just gonna run NPM test to just validate that my tests will successfully pass. Okay, so my tests run locally. All I have to do is say NPM test, and that script lives in my package JSON, and it will run my tests automatically. Awesome. Now, what is this application, you say? It's just a very simple Node web app, and I'm going to actually run it locally so that we can see what the interface is and make some changes on the fly. So I'm gonna go ahead and go back to my local host. Localhost. Here we are. Okay, cool. So this is our local host. You can see this is an AI powered calculator because if you add 1 + 1, it automatically knows it's 2. So it's pretty intelligent. And you might have seen this in the past from a previous stream that we did. So it should be a little familiar, but I think what we're going to do together is modify, I don't know, the color of this just to validate that we're actually pushing to the deployed version. And I do have this deployed already. So check the URL. It's localhost right now, but I also have it deployed to Azure. So you can see that they're both this blue color here. And I'm going to ask if anybody on the line actually wants to, anybody on the stream wants to share, you know, a hex. I'll actually change the background color to that and drop you in the your GitHub handle in the comments here. So go ahead and drop in a color that you'd like to see this background color be. And I'm going to go ahead and update this and push it back to our GitHub repo so we can get started. So if anybody wants to share a color in there, I'd encourage you to do that. And we'll go ahead and update this and it'll make its way back into prod. Otherwise, I have my own ideas. We got some purples. Go ahead and, if you want purple, I'm happy to do purple. I don't know, can I just drop in a purple here rather than a hex? I probably could. So go ahead and drop in a color and then your GitHub handle as well. Everybody wants purple, okay, purple it is. And then the GitHub handle for, who said it first? So it's quiescences. So, hey, I apologize, I totally botched, I'm sure, how you pronounce your handle. But it's a great handle yet. So go ahead and drop your GitHub one in there. It's Elisa, awesome. Oh, so I got a couple folks drop in here. So, all right, this is what we're gonna do. I saw a few come in there. So we're just gonna like paste in all of y'all so that nobody's left out. And hopefully you don't get spammed by trolls later on who are like, oh, I'm gonna spam all these people. So we got a bunch of suggestions. Let's see let's see what the background is if purple works. I think you can just define that color with that actually. Did I save that file? I did. So let me just run it again and validate that we have purple. Wow, amazing. Okay, cool. But this is important because it's going to validate that our change makes it from local back into our staging environment really on Azure, right? So, okay, so we've changed that. I'm going to look to see what my change files are. Okay, so this is my test results. I produce test results dynamically, but I'm really only going to push the changes that I've made to my CSS file. So Team Purple Unite, I love that. Awesome. Thanks, Hollywood. Cool. Okay, so I'm going to do just, what did I have changed? So I'm just going to add the changes I did to public. We're going to commit Team Purple Unite. I love that. That's fun. And I think I didn't push, so I'm just going to get pushed. I think I'm actually pushing to master, which I would encourage you not to do in your own development, but you know, do as I say, not as I do, right? That is kind of the classic thing there. So let's go back together here. We should have pushed back to this repo 22 seconds ago. We updated Team Purple Unite. Let's see what that change was. We dropped a bunch of y'all in here, so thank you for your contributions. It's always fun to hack along with folks out there, so very cool. Okay, we ran the app locally. We talked through some of the security capabilities at the organization level. Maybe before we implement CI/CD together, let me just show you how you can implement these at the repo level. If you're saying, hey, I just want to validate how these capabilities work, how they surface in the developer workflow before I scale my implementation, which I wouldn't blame you for that, right? It's kind of logical. We do the same thing ourselves, right, as we're rolling out these new features. So let me go to my settings tab. And let me go into security and analysis first. Okay, so this is a very familiar interface. We just looked at how you do this at the org level. So you can also turn on all these capabilities at the repository level itself. Okay, and so you can enable them. By default in this organization, we have it all enabled. And so you've already seen some security alerts surfacing and some pull requests popping up as the Penapot saying, hey, you're already vulnerable. And all these hackers on your Twitch stream are gonna start, you know, hacking you and stealing all your stuff. So, okay, you can implement it here. And there's also on the security page, I do want to do a quick sneak preview. From a code scanning perspective, this is what you'll see when you have advanced security enabled in the public space or in your enterprise org. You'll start to see these code scanning alerts or this capability pop up on your security tab. And then you'll have these workflows that you'll be able to enable on the fly. So I'll show you what that experience is when we're implementing SaaS together, but we're just not there quite yet. So I just wanted to tease them and make you aware. And I know you're all dying to see what my secret is again, so you can troll me, but I'm going to hold off on that just for now. Cool. All right, so let's go ahead and let's actually just implement a CI workflow together. Again, for the folks who have been here in the past or seen other, streams, this should just be a little bit of a refresher for you. It's kind of simple, right? How do you implement CI with a Node application using a pre-existing workflow from the community? I'm going to go ahead and walk us through that. So I'm in my repository. I'm just going to go to the Actions tab. I'm going to scroll through my workflows. In this case, we have some org level workflow templates. So these are defined by what is our CI/CD team at, inside of our demo organization. So they standardize on these projects and I can adopt them and use them if I choose to. Actually, as a matter of fact, it looks like someone dropped a perfect Node workflow in here. So I'm going to use that. Oh, this was workflows made for my JavaScript repository. These are the templates here. Okay, workflows created by Octo Demo. So these are the org templates. And these are the ones that are just using the detection of the languages that I'm using. So in this case, it's Node, and it looks like it's running CI. So I'm just going to go ahead and set up this workflow. All right, so I appreciate it. If anybody wants to drop in what I should name this file, that would be awesome. Otherwise, node.js.yaml. I feel like that, I don't know that that is necessarily the best extension, but maybe it's a new default. So let me know what you want me to name this workflow, and I'll name it as such. And I'm just going to walk through really quickly because I think this might be familiar with some of you all, what this workflow actually does, and then we'll continue to roll forward a CD before security, okay? Very quickly, we define the name of the workflow, and you'll see that pop back up in our live logs. From line 6 to 10, you see the event triggers and how we filter those triggers on push, pull request, branch, directory. And then we have a matrix build. So now we're testing not just against a specified node version, but a matrix of node versions on the fly in a Linux environment using the latest GitHub Linux runner. And then we're running basically, if you look past all this kind of setup steps where we pull the latest version of your repository, we're actually running CI. So let's go ahead and not run a build because I just don't think we need that. And then we're just going to run npm install because I did not push my node modules. I'm going to run npm test. Actually, I think somebody in our last stream said npm CI also installs your dependencies, but I just don't have confidence because I just am not confident. So I'm just going to do this as, I don't know, CI workflow. I didn't see anybody drop anything in there. So I guess it just, nobody cares. So I'm just going to name it as CI workflow. And then we'll just keep rolling forward, ci-workflow.yaml. And let's go ahead and just commit this directly back to master, which a push to master should trigger it. So we'll see pretty quick whether or not this, this works. And again, be aware of this. In this .github directory, you're going to be doing a lot more work if you're doing any level of configuration or customization across your orgs or across your repos. This is where you're going to be defining your CI/CD workflows using actions. In the future, policies as code will live here. That's a little bit of a teaser for you. And also your code scanning workflows and any workflows you define around scanning your dependencies or other DAST tools. Okay. So here is my workflow. It's running, it's in progress. You can see that I've triggered it and you can do some filtering on that. But okay, so it looks like our test may have been successful for node 10, which is awesome. I just wanted to validate that before we push it. So yes, you can see the live log spit out. We got some successful tests. That's cool. Excuse me, awesome. Okay, CI is implemented. For those on the line who are like, hey, let's just get to the security, man. That's what I came here for. We're gonna get there very soon. First, I'm gonna implement CD. So let's go back to actions. Let's go back to create a new workflow. And this is the awesome thing. I mean, so most of us as developers have used a tremendous amount of tools to either in terms of CI/CD, in terms of AppSec tool implementation, whatever it is. Having that community is so powerful because a lot of what we want to develop already exists out there and we just have to do some small degree of customization to it in order to make it our own, right? And so that's what this is really showing us. Hey, here's these templates created by these service providers. Look, we have an Azure web app to stand up, and we can use AWS, we can use Google. All these modern service providers have already developed these workflows for you to use, and that's super cool and helps make your work a little faster. So I'm going to deploy the Node.js to an Azure web app. It popped up with Node because it knows that's the technology that I'm using. I'm going to go ahead and set up this workflow. Okay, so actually it looks like initially the trigger here, so if you're looking on lines 15 to 17, the trigger is on a release created. We're going to go ahead and trigger this workflow, but I'm going to do something even more maybe primitive, if you will. I'm just going to say on a push to, how does that actually work? Maybe on a push to master. Is that what the syntax is? Something like that? On push to master. Okay. Oh, okay. So I think this actually should work even though it's giving me a dummy error. So let's leave that for now. We'll see if it throws an error when we run it. But it is shaking my confidence that this will run on the first try, but I'm always used to failing and I try to fail fast. So, okay, so the Azure web app name is the one thing we'll have to modify here. I just happen to be familiar with this workflow and I know there's some dynamic data that we're injecting at runtime. So the other thing you'll wanna note is, where is it? The publish profile. So this is how we're actually authenticating. Hollywood, thank you, I see. Yeah, so if you know the syntax that I should use for my event trigger, I would appreciate, just drop it in the chat and I'll just plug that in myself rather than fumbling around with a build failure. So the publish profile is a dynamic value that you should set using your native secret store. Again, that secret store lives in two places, at the org level, so anyone can consume them, or you can define specific repos that can consume your secrets, or you can define them at the repo level. So check it out. I've already defined the Azure web app publish profile here, just so I didn't have to drop that in on Twitch. But I do also have the org secrets here that are available for me to consume in my workflows dynamically. Something that's really cool that we do is automatically attempt to redact your tokens if you leak them into your logs, which is a very common attack vector that we've seen. Oh, okay. So Hollywood, he's saying something like, okay, so just, Oh, wonderful. Thank you. Awesome. So in that one, I'm going to tag at Hollywood. Thanks for that. Oh, okay. We're going to go to the next line and tag you. How's that? Cool. Always adding value. Very fun. Okay. So now we have the Azure web app name. We have npm installed, install our dependencies. I just don't think we need npm run build. I don't think we need npm run test either. Okay, and it'll probably automatically through Azure Web Apps run npm start. Oh, there it is, npm install, build, and test. So we're just modifying some of this workflow on the fly. Again, I didn't have to define this workflow from scratch. I just consumed it from what was already available in the community. So there is an API. I see some people trying to dig into the security aspect. There is an API that is available to consume any code scanning alerts or dependency alerts that have surfaced. I think I lost you there for a second, but there is an API that exists for any alerts that come across your repository, and you can aggregate them for your organization as well. So you can go ahead and just commit this new file. I think I lost internet for a second there, but I'm back. We're live. Okay, so we want to see if, where is it? It is Pocket Calculator. I think it's here. Yeah, so we want to see if this live app actually turns purple. The team purple was pretty adamant about the color we used. So we're going to see how that goes. Oh, what is this? It's running my CI first because I pushed the master. I should have known. I think we also, did we say on pull request or we said on push? I think it was on push. Oh, that's the wrong workflow. Did I not commit that workflow? Or do I do it to another branch? I don't know what happened. Did anyone see what happened? Let's go back to my commit. And I see create azure.yaml. Okay. One changed file. Right back in a master. But I don't see my file. Maybe I need to do a hard refresh. Let's see what happens. Here's my CI workflow. Funky stuff. Create azure.yaml, and it still triggered the pipeline. Node CI. Okay, so I see my CI ran. It's almost like I ran the commit, but for some reason didn't actually commit the file. So let me just make sure that I do that. I guess I'm just gonna have to, because we're live on the stream and I don't want to waste your time troubleshooting my CD workflow. Let's go ahead and just reset up a workflow and say, I don't know, this is a CD workflow, and it's probably something that I messed up on the fly. So we're gonna say on push, and Hollywood gave me branches to master. Every engineer on the line's like, we want to go back and troubleshoot to see what the problem is. And I agree with you. I also am going to spend a little bit of time digging into that, but just for the sake of getting to the security piece, I'm going to fly through this myself. So let's go ahead and commit back to master, create CD workflow. Okay, that's so funky. I don't know what happened there. I lost it in the ether. But the good news is that our CD workflow lives in our repo now. And while that is being run and we're deploying back out to Azure, hopefully it runs successfully. We'll see when it comes back. Let's go ahead and implement some of the security capabilities and see where we've gotten so far. So I'm a developer, and I happen to always see this banner all over my UI, and I ignore it no matter which repo I'm in. But it's telling me, hey, if you have a vulnerability in any of your dependencies, or that I do have a vulnerability in one of my dependencies, and so I should see the Dependabot alerts. And so this button will take me to the security tab, where I'll have visibility into my Dependabot alerts. And so this is a list of the packages that I'm consuming that have a known vulnerability that map against some given CWE or CVE. So we sort these by default, I think by severity, or maybe these are sorted by newest by default. And we show you the manifest that they're in, when they were committed, and when the vulnerability actually surfaced. So this is really interesting. And this is actually a really good example to start with. So a few things here. First of all, it says Dependabot cannot update to the required version. And so in the case that we'll introduce a regression by bumping the version of your package, we will not automatically open a pull request. And so there is a compatibility threshold that we actually even propose to open that PR on your behalf. But we're here saying, hey, kind of is a package you're consuming, and it kind of makes you vulnerable to CVE, this CVE here, and you can dig into what the details of that are yourselves. But we can actually dig into one that opens security updates. Let me go into my PRs. I know I should have something from Lodash, at least always has a vulnerability. Okay, so here's this package I'm consuming. This one happens to be low severity, so that's not a tremendous problem, but you can see that Dependabot automatically opened this pull request for me. I have an 80% probability or compatibility score. So that's the probability that I'm going to introduce a regression through this. But the nice thing is we can set our checks so that on pull request, if we run our CI, on pull request, if we run our code scan, we'll report that back in this PR workflow. And so you'll have better visibility into whether or not this is going to introduce a regression for you or your teams. And hopefully your developers then just say, okay, it's that simple. I'm just going to go ahead and merge this, right? And after your test pass, you see there's no regressions, it'll get bumped back into your working version of your application. So that is fundamentally what we're talking about when we say shift security left, right? We're making this ingrained in the developer workflows in every sense of that phrase. And so I'm a developer, I would just merge this PR if it dropped up here, especially because then I get to see nothing open in my pull requests, which would just make me feel so good. So if you have any comments, questions along the way, feel free to drop them in the chat. I know Hollywood is also working with some of you, so that's great in that space. So let's see if we deployed. Okay, it looks like created CD workflow ran successfully. So let's go ahead and see this workflow. It looks like, okay, it set everything up, deployed to Azure. And last time we did the same deployment, we were waiting to see, boom, whether or not it was going to deploy. Okay, so now we have CI integrated with Actions. We have CD to Azure with as well, which is awesome. And now let's implement scanning workflow together. Okay, so I'm going to go back to this repo. I'm going to go back to this repo interface here, and I'm going to start with where your developer lives, right, in kind of the root of the repository. So let me go into my security tab, into my code scanning alerts, and set up my first code scanning workflow. Set up this workflow. So here we are. So this is a very familiar experience now that we've implemented CI and CD with Actions, right? We have these workflow templates that you can consume or define as an organization in the future in order to just enable DevSecOps as part of your developer workflows, right? So this is named CodeQL, which is kind of the secret sauce under the hood of code scanning. We talk about it in that blog post that we shared with you earlier. The resource to download it, it should be linked in the chat. So I'm just gonna name this code scanning. I'm gonna name it code scanning, which some people have said, hey, code scanning means a lot of things to a lot of people. For me, it just keeps it super simple for now for us all on the line. So here are the event triggers, very similar to the experience we had with our CD workflow. So it says, is this gonna run on, this workflow will run on push in master. I'm gonna remove that comma in case it's breaking, or pull request on master again, and it's also gonna run on a cron job. Okay, and so again, I would encourage you to keep your pull requests as part of your regular scans, right? In terms of level 1 maturity, it is okay to enable and integrate code scanning as part of your pull request workflows, and your developers will then see in the pull request whether or not they're introducing any vulnerabilities. That's awesome. But what I would kind of encourage us to consider is whether or not we want to actually block their merge when we surface vulnerabilities. And again, that's because early on in our AppSec programs, our practices may not be mature enough to justify the amount of disruption that it really creates when your developers are trying to deliver features for the business. And of course, we always encourage you to keep the cron job on. So keep this schedule event on, because someone may report a 0-day and your developers may not actually make a contribution that triggers a scan, but you'll want to know whether or not that 0 day is impacting your application, especially as GitHub includes additional scans for that new vulnerability, right? So you'll want to have these on schedule as well. And so walking through the workflow a little bit more, you can see we just check out the latest version of this repository. I'm going to skip through some of this stuff just a little bit. There's great documentation. Hollywood, if you don't mind sharing the documentation on, I think it's docs.github.com for code scanning. So folks who want to look at the syntax more deeply for workflows and how to actually include additional customization. So, you know, say we're just scanning for a specific subset of vulnerabilities right now. Maybe you want to expand the number of libraries that you're actually you know, using to scan your application against, and you'll be able to do that by adding another layer of customization. Hollywood's going to share the details on how to do that. Maybe you want to scan for quality, code quality. You'll also be able to do that by including a library. So we'll attempt to automatically build your application. Obviously, this is a JavaScript app, so that's not going to be a problem. And then we just perform the analysis. And this is a really cool, I'll show you what it looks like, or the guts of it at least, in and when we run this workflow. And I love it because you can actually see each query that's being run. And again, the query is defined as CodeQL, which is a query language that models security vulnerabilities. And we run those vulnerabilities, those queries, against your application in order to see whether or not you're exposed to these semantic vulnerabilities. And I actually haven't planted, and maybe I'll be kicking myself for this, but I actually haven't planted any semantic vulnerabilities back in this app. So that something surfaced. I do have an application, of course, that does, and I'll show you what the experience is there, but I haven't done that here. And I think when you're choosing yourself as an AppSec program manager, whether or not you know, what type of repo you want to enable this on initially, I'd encourage you to choose something that's a large and meaningful application for your business, and something that your developers are actively working on, right? And that you're partnered with the security champion or the developer lead on that team. And so you can see how it affects their actual workflows as developers who are shipping features every day. Right, okay, so let's go ahead and actually merge this. I think for now this is okay. We got a bunch of triggers on here, and I'm just gonna commit it back to master. So now we're gonna have, check out these workflows. And again, this is why I said, get really familiar and comfortable with this idea of the .github directory. So you can see, this is where all of our workflows live. We have the CD workflow, the CI workflow, and code scanning now fully integrated into this repository. And you can roll this out at scale. You can also automatically write to your repositories. We have scripts to enable you to do that. And you can, I'm sure, develop your own as well. So while that scan's running, I'll go back and parse the logs for us all in a minute here. Let me show you what the experience is if I've leaked a secret, right? So if I'm a repo admin or an org admin, I might want to know whether or not somebody inadvertently pushes a token back into my repo. So I'm going to go to my security tab, and I see that I have 6 open vulnerabilities. We may see code scanning alerts pop up here. The reality is that this application is small, and so we might not see any meaningful vulnerabilities, and that's okay. We don't want to create a ton of friction and noise where we don't have to. And you know, I have this conversation all the time with folks who are like, well, I just want to know whether or not it's working. And if you want to light it up like a Christmas tree, you can do that. Include, you know, additional queries for quality checks and additional security checks, and that'll light it up. But I think initially we include a very accurate subset of scans to ensure that if we say you have a vulnerability, there's something like, based on the research we've done, an 80% true positive rate. So the probability that that vulnerability should be actioned or at least reviewed is 80%, which is a tremendous differentiator versus any other tools that you might already be using. And again, this is all baked back into the experience. So if we map it back to DSOM, you'll say, well, what's the consolidation experience like? Right? And so it's all baked in. And so that's a really tremendous value add for your developers and for you who's implementing this thing, right? So let me go back to my detected secrets. And before I actually show you what the secret itself looks like, let me go back to my profile itself and just look at my tokens. Let me go to my settings, and I should be able to see my, let's actually do this. So just want to make sure that as we're showing this in the future, that we have the ability to make sure this token is immediately revoked as I show it to you. Because what we do here is actually pretty cool. If we detect that you have a GitHub secret, that secret is actually tested to see whether or not it's still an active token. And so we'll mark it closed if you've already invalidated or revoked that token. For other service providers, you do have to go back in and revoke the token and actually mark that secret as, you know, remediated or closed, if you will. So let me go in and actually show you what this looks like. This is the experience. We'll surface a GitHub personal access token where we know who the service provider is. And I'm actually, this token no longer exists, so it might actually close itself while we're talking. But you can see the directory and the file itself that this is a part of. You can see the token itself. It highlights what line it's on. And you can then say, hey, I've gone and I've revoked this token. And we'll include an audit history for this token, so you can always go back and reflect on it. And then you should see in secret scanning under closed where that personal access token lives. Okay. So that's your token remediation workflow. Pretty simple stuff. There's no integration of other tools. Everything's already consolidated, right? And that's why DSOM makes so much sense to measure against, or such a great validating framework, really, if you will, because so many of those axes, the depth of static and dynamic analysis, and the consolidation experience and the intensity is very easily defined when it's all baked into the same platform. So code scanning alerts. I don't know if we finished our workflow run. No, it's still running. The initial time, nothing's cached. So the initial scan will take an extended period of time. Okay, so this actually did finish just now. Cool. So let's look at, I did want to show you what it actually looks like when we're running the scan. So let me go back here, and it should be something like maybe analyzing JavaScript. Yeah. So I wanted to show you this because I think it's really illustrative. And I think on your screen, it's probably tiny and you're having trouble reading it, but that's okay. So the point is, I wanted to show you that what we do is go through this library of queries defined as these .ql, CodeQL queries that model vulnerabilities, and then run each of them against your application. And that's why we say you can write your own queries as an organization and customize it. You can include your quality scans, additional security scans, and we just include those as the CodeQL analysis is actually happening. And Hollywood shared that in the docs. So if you have a question about how you can incorporate additional libraries or a little bit more information about CodeQL generally, feel free to drop your questions in the chat there. And Mr. Hollywood, I'm sure we'll get to you. Okay, so what do we have now? We have already, it feels like we haven't done much, but the reality is we've already implemented token scanning. We've implemented our SAST tooling. We have SCA enabled with Dependabot and your dependency graph and scanning your dependencies. Now, the last thing is dynamic analysis. So we don't have a dynamic analysis native tool yet, but the cool thing is if you go to Actions, actually, maybe I'll go to Marketplace, I think. So I'm gonna create a new workflow using Zap, and Zap is just an open source tool. I think they also have an enterprise offering, but I use the open source baseline scan out of the box. It's pretty solid stuff, so I'd encourage you to explore that as well. So I'm gonna go to my Marketplace, and I think I'm gonna look for Zap. You can see that I've been here before, and you can see, so Zap has already shipped an Actions integration. Again, most service providers that you use will have integrations available here, so that's super cool. Okay, so here's the baseline scan. Go ahead and check this out on your own. Hollywood, do you mind just linking this baseline scan for the folks who are following along or in the future looking back, link to this baseline scan action for Zap? I'm just gonna go ahead and look at what the usage is. It looks like I can just in my steps integrate Zap like this. Okay, so let's see what that experience actually is. So I'm gonna say, what if I could just click use latest version? What would happen then? Oh, it just allows me to copy the code, but I probably have to point it, because again, we wanna point it back to our deployed application, right? So maybe I'm just gonna keep this handy. And I'm gonna go back to my repository, and I wonder if there's a predefined workflow so I don't have to do this from scratch. Okay, I'm sure that skip this and set up a workflow yourself. Okay, I'm sure there is, but I'm not gonna spend your time doing that together. So I'm just gonna call this a dast scan.yaml, okay? And this is not gonna be CI, this is gonna be a dast scan. Okay, and so we're gonna run it on a push against master is the, again, this is that familiar workflow. We're committing this back to the .github directory, right? So here we are, we're setting up in an Ubuntu environment, we're checking it out, run a one-line script, we're gonna echo hello world, but I just wanna do this. Oh, I already have steps, don't I? Let me just validate, okay. So this is what I'm gonna do, I'm gonna put this here. All right, so that should work. I'm gonna copy my URL for my service that we shipped. And I'm just gonna go ahead and paste this in here. And again, I don't know whether or not this is gonna surface any vulnerabilities. I'd imagine from a DAST perspective that it will, just because I haven't gone through the pain of actually, you know, putting the security and controls around just this demo environment, because I'm gonna tear it down right away. But let me go ahead and commit this file back to my master branch, and let's just see what happens. This Zap scan is really cool. It runs the baseline scans like OWASP top 10 type vulnerabilities on your app if it's deployed. And then it also produces an issue of a report of all the vulnerabilities it found on your app. And that's really nice. And so now you can see we have DAST, we have code scanning, we have CI/CD. It's all baked into the developer workflow. And that just happens by default, right? So any of these advanced security tools you're using from GitHub, it's already shifted left fundamentally. I mean, that is what we approach this problem with, is that mindset. We want to put security in the hands of the developers. And that's what you asked for. And, you know, I just get to stand up here. Hollywood also, you know, in the chat, we get to take a little bit of credit for the amazing engineers at GitHub who are doing great work. So thank you all for that. Okay, so let's look back in the actions workflow. So so everybody's subscribing to push. So you would obviously have to refine the events that trigger your workflows. So you don't trigger all these workflows every time there's a push, or if you're doing a development on a specific branch. But in this case, I'd love to see what my DAST scan, how that's gonna do. It looks like it's just getting ready to run. Maybe it's running already. Could have been named better, but okay, we set up the job. We run a one-line script, which probably just says, hello world. The Zap scan failed. I wonder if it failed because it actually found vulnerabilities, or if it failed because it just didn't run. We'll see. Okay, so this is really interesting. This is what you see, actually. It failed not because the integration itself failed. It failed because there were these new warnings that surfaced, right? And so this is where you could integrate as your program continues to mature back into a developer workflow, right? So here are some of the vulnerabilities. If you want to hack me before I tear down my my service on Azure, and I'm not daring you, you know, these are the types of vulnerabilities that I've created in that service. And I believe that this is also going to create an issue. Yeah, check it out. So this also creates a Zap scan baseline report. And this shows me, hey, here's your new alerts for your project that you have deployed out there, right? And it just kind of crawled it and produced all this cool stuff. And I can download the report and take action from there. I'm sure there's some other automation you could build around that to say, hey, if I produce a Zap report that happens to have vulnerabilities on it, I want to, you know, either open another issue or a Jira task that actually creates a work item for my developers to come back and action it. But it's right here where the developers live in that centralized repository interface, right? Let me go back to code scanning. Okay, that's interesting. We did get an alert. So we did get one alert with our code scan, and this will maybe be one of the last things I share with you. I don't know how meaningful it is. So let's see, unvalidated dynamic method call. So you remember we ran our SAS scan before. I wasn't sure if we're gonna get any actual alerts. This looks like a low severity alert. So this is actually a warning, not an error. So your developers might say, hey, I'm gonna look into this, but it's not a critical priority, right? The cool thing though is this experience that I have, right? I surfaced that specific vulnerability. So you could go back, let me go here first. I surfaced this specific vulnerability. It says where the vulnerability lives in the file on line 49 and what file and directory it's in. It was detected 7 minutes ago on the master branch. So let me go ahead and click that. I can see the file itself. I can see the nature of the vulnerability. As a developer, I might not know necessarily, you know, what CWE 754 is, right? I know I personally am just not a subject matter expert. So I don't know what this vulnerability is. And so I would have to read the recommendation and what this CWE points to, okay? And the nice thing is we actually give you suggestions in terms of the code that you can use to patch this vulnerability in your app. And then of course, as you go back and remediate it, you'll have, again, that familiar experience where, let me just show you the call path. So it looks like there's 1, 2, 3, 4 steps. So it's actually a pretty deep vulnerability that it'd be very difficult for you to manually find, right? Where we're sourcing some query parameter comes in and it's probably just unsanitized by the time it makes it. Yeah, so it's just unsanitized or unchecked by the time it's actually executed. So from source to sink, we can see the call flow, nice call flow analysis and audit history. I'm gonna mark it, you know, if I actually patch this vulnerability as a developer, and anybody with write access to your repo can see these alerts. And that makes sense, right? Because they should own, as a developer, the security of the applications. And we're all kind of agreeing to this new world where developers have that sense of ownership. So I could see it in the pull request workflow. You could surface it there. I could come back here and mark it as I'm not going to fix it if I choose to not fix it. But otherwise, once I patch it in my source, it's actually going to move from being an open vulnerability over to closed, okay, automatically for you. And so one last thing I want to share with you before I let you go is I switched repositories. So you probably saw that switch out right from under your face. So check this out. Here's a repo that has 63 vulnerabilities. But what's really cool I wanted to share with you is the PR workflow integration. So Isaac created this vulnerability in this pull request that he opened. I came along and I said, hey, this looks like it introduces some vulnerabilities. Let's talk about that, right? And the reason I knew it introduced vulnerabilities was because I saw the code scans actually popping up in the status checks saying, hey, your code scan failed, some vulnerabilities surfaced. You can still merge it, right? Because we're just not at the maturity where we want to block the merge, but something's going on here. And if I go to files changed, I can see if I scroll through my files changed, give that a minute to load. Through my files changed, I can actually see, again, the line that this specific vulnerability lives on. And I can see the paths for this specific vulnerability from a request coming in all the way down to when it makes it to the back end from source to sync. And this is fully integrated back into the pull request. And this is fully integrated back into where your developers live and do their actual development, right? So if I go back to code scanning alerts, I'd actually be able to see this as a developer who's just living within GitHub and patch it myself. All of these insights will bubble up to a security center that'll give you a view of all the actionable insights across your organization. So you'll have that top level view as an AppSec manager. And as this continues to mature, obviously we'll continue to roll out those features. And so we're going to go GA with code scanning and I believe secret detection this quarter. So that's coming soon. I hope you're as excited about it as I am. And it was really a pleasure to be here with you all. I think that's what we had in terms of the content we had prepared to share with you. We're going to stay on for a few more minutes after this. If you have any questions, feel free to drop them in the chat. Myself and Hollywood will respond to them. And again, for the folks who joined late, go ahead to this resource here. I'll drop it in the chat since now I'm no longer leading us through the demo itself. Go ahead to this resource here, download the PDF, explore what the DevSecOps maturity model is, and how you can apply some of those practices using advanced security capabilities. And again, thank you so much for your time. It was great to have you here. It's 3 o'clock in the East Coast. It's almost time for a beer, so we're getting there. I'll stay on for 5 more minutes until 3:05. If anybody has any comments, questions, otherwise, feel free to drop and have a great weekend.